Welcome to the course on an introduction to information theory. In today's lecture, we are going to continue our discussion on Limpel-Zev algorithm. Today, we are going to talk about another variant of Limpel-Zev algorithm, which is Limpel-Zev-Welch algorithm. So we will, in today's lecture, we'll talk about Limpel-Zev-Welch encoding as well as decoding, and we'll illustrate this with an example. So in 1984, Terry Welch published an improved implementation of Limpel-Zev 78 algorithm, which was published by Limpel-Zev in 1978, and we are going to talk about this algorithm. So in this algorithm, we create a dictionary that contains a list of previously encountered phrases along with their associated code word. So we are going to create a dictionary of previously encountered phrases and we'll put them in the dictionary. In this procedure, the input is incrementally passed into phrases where each new phrase is a concatenation of an old phrase that has already occurred in the past and a new symbol which we will call as innovation symbol. So we are going to look for a sequence which is already there in the dictionary plus a new symbol which is an innovation symbol, and we'll put that in our dictionary. So as I said, in this method we are incrementally parsing the input into phrases where each new phrase is a concatenation of an old phrase that has already occurred in the past and it's there in the dictionary, and a new symbol which we are calling an innovation symbol. And the same dictionary is created at both the encoder as well as the decoder. And the list of these phrases in dictionary is indexed by a integer index. To start with, we will initialize our dictionary to all one length phrases. So let's say your output is binary, so we will put 0 and 1 in our initial dictionary. And a code word is a pair representing the code, that is the index in dictionary, and of the prefix of the new phrase, and WK is the innovation symbol. We'll talk about this when we explain it with an example. So as we noticed in the previous slide, what we are doing here is we are adding new phrases into our dictionary which is already not there. Now if our dictionary gets full, because our dictionary typically will have fixed size, then what should we do? So we can follow one of these two approaches. In this approach, we can reset half of the phrases in dictionary that contain the oldest unused phrases. So phrases which have been there in the dictionary but which are not appearing in the new phrases, like phrases which have not been used, those old phrases can be reset. That will create space for entering new phrases. Or the second approach could be we do not reset the dictionary, we continue coding with the same set of phrases that are already there in dictionary. So we do not update the dictionary and we continue coding using the older phrases. Another approach could be we reset entries corresponding to short phrases that are already prefix of larger entries, and these larger entries are already there in the dictionary. So for example, if you encounter 01, and if 0110 or 0111, 0100, 0101, those are already there in dictionary, then there's probably not much point keeping 01. So that's what I meant when I said reset entries representing short phrases. So if this is the size of the dictionary, So we will require these many number of bits to represent our code words. Alternately, we can also use coding of positive numbers, which was given by alias. We can use that to encode these code words. Now this alias coding of positive numbers we'll talk about in the next week's lecture. So let us take an example to illustrate how Limpel-Zev-Welch algorithm encoding will work. So this is a 24-bit binary sequence that we want to encode using Limpel-Zev-Welch algorithm. Now remember, this is a universal source compression algorithm, so this algorithm does not need prior information about the distribution of zeros and ones. So this is the sequence that we want to encode. It is 0 0 1 0 1 1 0 1 1 0 0 0 0 1 1 0 1 1 0 1 1 0 0 0. This is a sequence that we want to encode using Limpel-Zev-Welch algorithm. So what is the first step? The first step is to initialize the dictionary with all length 1 phrases. Here we are talking about binary sequence. So those length 1 phrases are 0 and 1. We are indexing them by 1 and 2. Okay. Alternate representation I will talk about in a little while. Let me first complete this table. So the two length 1 sequences is 0, which is indexed by code word 1, and this phrase 1, which is indexed by code word 2. So initially my dictionary will contain 0 and 1. Now let's look at the encoded the sequence that you want to encode. So the first bit here is 0, right? That's there in the dictionary. Is 0, what's the next bit? 0 0. So this next bit is 0. Is 0 0 there in the dictionary? No. The only bit in the dictionary is this phrase 0 and phrase 1. So we can only encode 0 here. And what is the encoding of 0? 0 corresponds to this code word 1. So that's why you see 0 has been encoded using 1 here. Okay. Next, we looked at the next bit, which is 0. Now is 0 0 in the dictionary? At this point 0 0 is not there in dictionary. So what we will do? We will put 0 0 in the dictionary. So we will add 0 0 in the dictionary, and that's the code word number 3. Okay. Now this alternate representation, as I said, each new phrase can be written as concatenation of an old phrase and a new innovation symbol. So this 0 0 can be written as 0 concatenated with a new symbol 0. And what is 0? 0 is my code word 1. Right? So this code word 3 can be written as this code word indexed by 1 and this new innovation symbol, which is 0. So the alternate representation of this is the phrase denoted by code word 1 and then followed by an innovation symbol 0. Now, so we put 0 0 in the dictionary. So now let's look at 0 here. The next bit is what? Next bit is 1. 0 1 is not there in the dictionary, so I can only encode 0. Please note, I am trying to find the largest phrase which is already there in the dictionary, and that I am encoding it. So since 0 1 is not there in the dictionary, I will only encode 0. And what is 0? 0 is my code word 1. As you can see here, 0 is my code word 1. 1. This is my code word. Phrase 0 is my code word 1. So this will be coded as 1. Next, we are looking at 1 here. Let's look at the next bit, that is 0. Is 1 0 in the dictionary? No. Now remember here when we encountered 0 followed by a 1. So this was not there in the dictionary. So what we have to do? We have to put 0 1 in the dictionary. So I put 0 1 in the dictionary, that's my code word 4. Now 0 1 can be written as code word corresponding to 0 concatenated with a innovation symbol which is 1. And what is the code word phrase 0? It corresponds to code word 1. So this can be written as code word 1 concatenated with a new innovation symbol 1. So we are at this point here 1. Now 1 0 is not there in the dictionary, so we will only going to encode 1. And what is 1? 1 corresponds to code word 2. So this will be code word 2. So far we have encoded 0 0 1, that is code word 1, code word 1 and code word 2. Now as we can see, if we look beyond 1, 1 0 is not there in the dictionary. So what are we going to do? We are going to put 1 0 in the dictionary. So 1 0 will be put in the dictionary, and that is my code word indexed by 5. Now we continue our encoding. So the next bit is 0. Now look beyond this, 0 1. Is 0 1 in the dictionary? Yes, it's there in dictionary. Okay. What about 0 1 1? Is it there in dictionary? No, it's not there in dictionary. So what are we going to do? We are going to put 0 1 1 in the dictionary. So we are going to put 0 1 1 in the dictionary, and that's my code word number 6. And note that this can be written as code phrase 0 1 concatenated with the innovation symbol 1. And what is 0 1? 0 1 is my code word 4. So I can write in alternate representation, I can write this as 4 concatenated with the innovation symbol 1. So 0 1 1 I put in the dictionary. Now I am going to encode this. So what is 0 1? 0 1 is 4. So you note this will be 0 1 which corresponds to 4. Okay. Next, start with this. 1 is 1 there in dictionary? Very much so. That is this one. What about 1 0? Is 1 0 in the dictionary? Yes, it's there. Now let's look at 1 0 1. Is 1 0 1 in the dictionary? Not so far. So what we are going to do is we are going to put 1 0 1 in the dictionary. So we'll put 1 0 1 in the dictionary, and that is indexed by this code word number 7, and we can write it as code corresponds to 1 0 concatenated with innovation symbol 1. So what is 1 0? 1 0 is code word 5, and this 1 is the innovation symbol. So you can see that each new phrase that I am adding in my dictionary can be written as an old phrase concatenated with a new innovation symbol. So 1 0 1 I have put in the dictionary, and now I am going to encode 1 0. So what is 1 0? 1 0 corresponds to 5. So then this will corresponds to 5. Okay. Next, start encoding 1. Is 1 in the dictionary? Yes, 1 is here. 1 1. Is 1 1 in the dictionary? The answer is no. We have 0 1 0 0 0 1 1 0 0 1 1 1 0 1, but 1 1 is not there in the dictionary. So what will we do? We are going to put 1 1 into the dictionary. So that's 1 1, that's code word indexed by 8, and this can be written as concatenation of 1 with this innovation symbol 1, and this 1 corresponds to code word 2 concatenated with innovation symbol 1. So we are going to code 1 then. 1 corresponds to code word number 2. So we start from here. This 1 is already there in the dictionary. 1 0 is 1 0 in the dictionary. That's there. This 1 0 is there in dictionary. Let's look at 1 0 0. Is 1 0 0 there in the dictionary? Not so far. So then we are going to put 1 0 0 into the dictionary. So that will be 1 0 0. This is code word number 9. This can be written as concatenation of 1 0 with innovation symbol 0, and 1 0 is code word 5. So it's 5 concatenated with innovation symbol 0. So now that we have put 1 0 0 in the dictionary, we are going to encode 1 0, and 1 0 corresponds to code word 5. So that's why I have it 5 here. Okay. Next, I start with this 0. Now this 0 is already there in dictionary. 0 0 is 0 0 in the dictionary. Yes. So I continue further. 0 0 0 is 0 0 there 0 in the dictionary. The answer is no. So I am going to put this 0 0 0 in the dictionary, and that's code word number 10, and I am going to encode 0 0. 0 0 corresponds to code word number 3. So this is 3 here. Alright. Next we start with this one because we have already encoded up to this point. So this is 0. 0 is already there in dictionary. Start with 0 1. Is 0 1 in dictionary? Yes it is. That's this one. What about 0 1 1? Is 0 1 1 in the dictionary? The answer is yes. That is this. Now look at 0 1 1 0. Is 0 1 1 0 in dictionary? And we can see it is not there in the dictionary. So we are going to put 0 1 1 0 into the dictionary. So we are going to add 0 1 1 0 into dictionary, and that's code word 11. This can be written as concatenation of code word corresponding to 0 1 1 with this new innovation symbol 0. And what is 0 1 1? 0 1 1 is this code word 6. 6 concatenated with innovation symbol 0. Now we are going to encode 0 1 1, which is code word number 6. Alright. Now we start from this 0. 0 is already there in dictionary. 0 1. 0 1 is also there in dictionary. That is this. 0 1 1. That is also there in dictionary. 0 1 1 0. This is also there in dictionary. Then 0 1 1 0 1. This is not there in the dictionary. So what we are going to do is we are going to put 0 1 1 0 1. We are going to put this in the dictionary. So we'll put 0 1 1 0 1 in the dictionary, and that's the code word number 12. And this can be written as concatenation of this code word corresponding to 0 1 1 0, which is code word number 11, and this innovation symbol 1. Now we encode this sequence 0 1 1 0, which is code word number 11. So that's code word number 11, and we start from this 1. 1 is already there in dictionary. 1 1 1 1 is also there in dictionary. That's this one. 1 1 0. Is 1 1 0 in the dictionary? The answer is no. We don't see any 1 1 0. So we are going to add 1 1 0 into dictionary. So this we are going to add to dictionary, and that's our code word number 13. This can be written as concatenation of code word corresponding to 1 1, which is this code number 8, and concatenated with an innovation symbol, that's 0. Okay. Now we are going to encode this 1 1. 1 1 is encoded as 8. Yes, this one. Okay. So now we start encoding from this point, because 1 1 is already encoded. So start with 0. 0 is already there in dictionary. 0 0. 0 0 is also there in dictionary. That's this one. 0 0 0. Is it there in dictionary? The answer is yes. That's this one. Code word number 10. 0 0 0 is this one. So then 0 0 0 can be encoded as 10. So our Limper-Zeff encoding of the sequence which is given here is basically coding of these numbers 1 1 2 4 5 2 5 3 6 11 8 and 10. So this is how we are building up the dictionary for Limper-Zeff Welsh algorithm, and this is how we are encoding our sequence. Now let's move to the decoding of Limper-Zeff Welsh algorithm. So LZW decoding is done using an alternate representation of the code word in an iterative fashion. So as I said, in the alternative representation, the code words are represented as concatenation of another code word and innovation symbol. So decoding procedure includes a timely generation of the dictionary from the received sequence, and we will illustrate that with the help of an example. So at the beginning of decoding, we are going to initialize the dictionary using code words of length 1. So in the previous example, we were considering binary sequence. So we will initialize the dictionary at decoder with 0 and 1. In this example, a phrase is added to the decoder dictionary after each new code word is received except the first code word. So you will see that we are going to add new phrases into the dictionary after we decode the sequences, and every received code word represents a prefix of a new entry into the dictionary. The innovation symbol for this entry is determined from the first symbol of the next decoded code word. If you recall, when we were encoding using LZW, so we were putting a new string into a dictionary which is already not there, which is a concatenation of some string which is already there plus an innovation symbol. So this new innovation symbol was getting encoded in the next phrase. So that's why the innovation symbol for an entry can be determined from the first symbol of the next decoded code word. If you go back here and look at this example, in each case when we are, let's say we are encoding this, so what we are doing is we are encoding 1 0, and this new innovation symbol gets encoded in the next sequence. Same here, we were putting 0 1 0 into the dictionary. Now the new innovation symbol here was 0. This was getting coded in the next set of sequence. So this was getting coded here. You can see basically each of these innovation symbols, they are getting coded in the next phrase, and that's why I made this remark that the innovation symbol for this entry is determined from the first symbol of the next decoded code word. Now let us take an example to illustrate that. So this is the same sequence, we just coded it, and this was the sequence in which this sequence was coded. So let's try to decode back our original sequence. So impulsive coding will give us basically coding of these positive numbers. From these positive numbers we have to get back our original sequence. So let's look at the decoding. So what we have received is this: 1 1 2 4 5 2 5 3 6 11 8 and 10. This is what we have received. Now the first step in decoding is to initialize the dictionary. And how are we going to initialize the dictionary? We are going to initialize the dictionary with length 1 phrases. We are talking about binary sequence here, so those length 1 sequence will be 0 and 1. So 0 is my code word indexed by 1, 1 is my code word indexed by 2. Alright, now next I start decoding. What I received is 1. Now what is 1? Code word 1 corresponds to phrase 0. So this will be decoded as 0. So this is decoded as 0. Next, I decode this. The next encoded sequence I received is 1. What is 1? 1 again corresponds to phrase 0. So this will correspond to phrase 0. So this is phrase 0. Now what do I need to do? The first bit of this new decoded phrase is my innovation symbol. So I need to add to this the innovation symbol. So I'm going to add 0 0. So I'm going to add 0 0. Why 0 0? Because earlier phrase was 0. Innovation symbol here is 0. So I'm going to add 0 0 to my dictionary. So I add 0 0 into dictionary. That's code word number 3. And in the alternative representation form, this is 0 concatenation with 0. So 0 is code word 1 concatenation with 0. Okay. Next, I receive 2. So 2 corresponds to bit 1. So then this will be decoded as bit 1. And what's the next thing I need to do? I need to add 0 1 into my dictionary. So the old phrase was 0, the innovation symbol was 1. So I need to add 0 1 to the dictionary. So I add 0 1 to my dictionary, and this is my code word number 4. And 0 1 can be written as concatenation of 1 0, which is code word 1 with 1. So that's why I am writing it in like this. Next, so 1 1 2 has been decoded. Next is 4. So what is 4? So if I look at my dictionary, 4 corresponds to 0 1. So this 4 will be decoded as 0 1. So this is decoded as 0 1. Now what is the first bit of this sequence 0 1? That's 0. So my innovation symbol is 0 and the previous phrase is 1. So I am going to add 1 0 to my dictionary. So then I add 1 0 to my dictionary, that's code word number 5. And again this can be written as concatenation of 1, which is code word number 2 with this innovation symbol 0. So I can write it as concatenation of code word 2 with innovation symbol 0. Next, I decode 5. What is 5? 5 is 1 0. So 5 is decoded as 1 0. So this is decoded as 1 0. This is decoded 1 0. Now in 1 0, what is the innovation symbol? That's 1. This is the innovation symbol. Now I add this innovation symbol to the previous phrase. So I get 0 1 1. So I am going to add this phrase 0 1 1 to my dictionary, and this will be my code word number 6. So 011 can be written as 01 concatenated with 1. And what is 01? 01 is my code word number 4. So code word number 4 concatenated with innovation symbol 1. So that is the dictionary entry number 6. Alright. Now the next received code word corresponds to binary coding of 2. So what is 2? 2 is just 1. So this 2 will be decoded as 1. So that's 1 here. Now the innovation symbol here is 1. The previous string was 1, 0. So I am going to add 101 to my dictionary. So I add 101 to my dictionary, and that's code word number 7. And this can be written as code word number 5, which is 10 concatenated with 1. So that's why in the alternate representation I am writing it at 5 concatenated with innovation symbol 1. Next, I decode 5. What is 5? 5 is 10. So this is decoded as 10. So then this is 10. Now what is the innovation symbol? The innovation symbol is 1. Previous phrase is 1. So I add innovation symbol here. So I am going to add 11 to my dictionary. So I add 11 to the dictionary. That's code word number 8. And this can be written as concatenation of second code word with this innovation symbol, which is 1. Next, I will try to decode 3. What is 3? 3 corresponds to 00. So then this is decoded as 00 and this is my 00. Now what's the innovation symbol here? The innovation symbol here is 0 and the previous phrase was 10. So I add this innovation symbol here and add this new phrase to my dictionary. So I am going to add 100 into my dictionary, and that's my code word number 9. In the alternate form, this can be written as concatenation of code word number 5, which is 10 concatenated with innovation symbol 0. Next, 6. Now 6 corresponds to 011. So this will be decoded as 011. So that's what it is. It is 011. Now innovation symbol here is the first bit, which is 0. Previous phrase was 00. So I add 0 here. So I am going to add 000 as my new phrase here, and that's my code word number 10, which can be written as concatenation of code word 3 with an innovation symbol 0. Alright. Next, 11. Where is 11? I don't have 11 in my dictionary. What should I do now? I do not have, my dictionary is only up to 10 now. So how do I decode 11? Now this situation happens if you go back to the encoding of the same sequence. This situation happens if we are going to use a string which has been put in the dictionary. If you look at this point, 011 has been put in the dictionary, and immediately after that you are using this 0110. So if you use a string which has just been put in the dictionary, you encounter a situation like this where a string appears which is not there in the dictionary. So 11 occurs, but 11 is not there in the dictionary. Now this will happen if a string which has just been added to a dictionary has appeared. So this one should start with 01011, and this bit will be nothing but the first bit of this. So this string 11 would be 011, 0. Now why it's 0 1 1 0? As I said, this situation happens when a string which has been added to dictionary has been immediately used. So this entry number 11, code word 11, should be of the form 0 1 1 something innovation symbol. Now what is this innovation symbol? Innovation symbol is nothing but the first bit of this new string, and the first bit of this new string is 0. So this bit and this bit here should be same, and that's why I have written that 11 should be 0 1 1 0. Okay, so I put 11 as 0 1 1 0 and I decode this as 0 1 1 0. So if you encounter a situation where a dictionary entry code word has come up and it's not there in dictionary, that means you are using a phrase which has just been added to a dictionary. So in this case basically we had this 0 1 1 which is phrase which just occurred. So the new entry should be of the form 0 1 1 and some new symbol. Now this new symbol has to be the first bit of the next decoded sequence. So the innovation symbol here has to be 0, and that's why this string corresponding to this code word 11 should be of the form 0 1 1 0. So we have decoded this. Next we go to 8. What is 8? That is 1 1. So we decode 8 as 1 1. Now what is the innovation symbol here? The innovation symbol here is 1. So we add this to this old string which is 0 1 1 0, and then this is added to the dictionary. So new entry in dictionary is 0 1 1 0 1, and that's my code word number 12. This can be written as concatenation of code word 11 with this innovation symbol 1. And finally this 10 is nothing but 0 0 0. So 10 is decoded, so this is decoding of 8 and 10 is decoded as 0 0 0, and here the innovation symbol is 0, so you add this here. So next entry here in the dictionary would be 1 1 0, because the old phrase is 1 1, that is this, and this innovation symbol here is 0. So the entry here would be 1 1 0, and this can be written as concatenation of 1 1, which is code word number 8 with this innovation symbol 0. So this can be written like this. So note that then this particular sequence has been decoded into string like this. Okay. So with this we conclude our discussion on Limper-Zev-Welch algorithm. Thank you.